at some of the contents of what we're going to talk about. So we're going to talk about what is it and how does it work, the main parts of the device, how to select it for your application, Intech brands and advantages, the accessories and the relevant additives, and we'll leave some time for some questions at the end. So we'll start off. What is it and how does it work? As you can see in the imaging here, a hydrostatic level transducer is a sensor that can calculate the head of pressure of the fluid above the sensing diaphragm. 0.1 of a bar is approximately equal to 1 meter of water depth, and the varying depth is translated into a scaled variable signal, which is typically a 4 to 20 milliamp or 0 to 10 volt DC analog signal. A 12 to 24 volt DC power supply is usually required to power that analog loop. Now we'll go into the main parts of the device, and here's one here. We have one of our level transducers from Jumo. This is our 404392, and typically the main parts are the lead. In this particular instance, it is a polyurethane lead. We have the main body of the transducer. We have the diaphragm, which is, as you can see, protected under a special cover right here, and any threads that may be required for the tip. I'll now break that down into a few other helpful bits and pieces. So the common lead, when it comes to the lead, it's really important to consider the lead material in relation to the medium it is being submersed in, and of course the length of that lead to the depth of the hole the sensor is going to be going down. The most common material is PUR, or polyurethane. It is used in most water, grey water and sewerage applications. FEP, or fluorinated ethylene propylene, is a special material which is similar to PTFE or Teflon. It's a very hard-wearing material in most chemicals and caustic applications. In the lead, you'll find an airline. I'll show you we can see in the image here an airline, the screen, which is gives it some electrical protection from any other signals. You've got your positive lead, and you have your negative lead. The airline is very important because it needs to be able to breathe and allow for that pressure equalization from being down a hole and underwater to normal atmospheric pressure. Now, this little filter here you can see in the image is very important to stop water from getting down. Make sure the airline has a filter to allow it to breathe, but stops any condensation or water going down. This will ruin the transducer electronics down the sensitive end, which is in the medium. So the next part is the main body, and in the images here you can see we have a few options to play with. You need to consider the medium again in choosing the best material for the body. The most common is stainless steel, and this can come in varying qualities like 306 or 316 or 310. 316 is preferable. Other materials for the body is POM, or polyoxymethylene. This is good for saltwater applications. And there's also PTFE, which is a type of Teflon and is very tough in chemical mediums. Titanium is the last in the list, and this is very good for chloride-containing mediums like swimming pools. Stainless and POM are the most economical, and PTFE with titanium tend to be the most expensive materials to have. The next part that we need to consider is the diaphragm. Now, common is stainless steel and ceramic, and less common is titanium. This is the most sensitive part that transfers the medium pressure to an electronic analog signal, as the main part will cause the unit to be damaged. That's why it's very, very important never to touch the diaphragm with a finger or any tool. Even if it's dirty, You'd be better off to clean it under gentle running water or chemicals that are compatible with the diaphragm material. You can see in this one here, I have a demonstration here. This one here is a ceramic diaphragm, and it's a flush diaphragm. As you can see, it's near the front. Another thing is it's very important to treat them with care. Do not drop or knock the transmitter, as this can damage it also. The larger the diaphragm, the less prone to blockage, but it is susceptible to damage. Consider a small recessed closed diaphragm for protection and for running mediums like water or diesel. You can see here, as you see, common is stainless steel and ceramic. Titanium is available. The diaphragm is very sensitive. The larger diaphragm is less prone to blockage. You can see here, you've got a closed recessed diaphragm. Here we have a recessed diaphragm, and it is open, so you can actually see the diaphragm in there, and the bottom there. And the one I've shown you is a flush exposed diaphragm. Next is the threads and the add-ons for diaphragm protection or blockage protection. This is important for being able to attach it to something or for anything to be attached to it. Internal threads are good for covers, for being able to protect that an open diaphragm. External threads for screwing on to underwater vessel or attaching a cage for thicker sewage applications, as you can see in the bottom of the image just there. Typically, an internal thread is standard for most of our transmitters, as they will come with a cover. If it needs an external thread, it will be a special order and will incur a lead time for special manufacture and delivery. Now we need to consider selection for your application. Mediums can come in all kinds of types. Typical applications are diesel fuel, water, grey water, which is like just dirty water still, and potential it can have potential of some lumpy bits. And there's sewage, which is thick, sludgy, viscous situations. And then there's caustic applications, like acids, chlorides, and things that can eat away at normal stainless steel. Another thing to consider about your medium, blockage from debris versus the diaphragm size. The thickness and viscosity of the medium versus the diaphragm size. Obviously, the thicker, the bigger the diaphragm you need. If it's going to be prone to blockage and have large debris, then you might need to consider a large diaphragm also, but consider protection of that diaphragm. Chemical reactions and corrosion behaviour on the diaphragm materials, and also the main body of the transducer. Other factors for selection, you need to consider the depth of the hole it's going down, and installation criteria. When it's being installed, it may be prudent to install in a pipe of a larger diameter to stop it from swinging around the water and being potentially sucked up in motors or pumps or banged about by agitating blades. Some Intech brands and advantages. We have Jumo, which has German precision and quality. They come with optional accessories and built-in overvolt protection, well stocked in New Zealand and common in ranges of 1, 2.5, 4 metres, 6 metres, 10 metres, 25 metres, and up to 40 metre depths. As before, I showed you this one here is an example of a German transducer with an open end. We also have a Hungarian brand called Nivelco. They all look very similar. With Nivelco, they have an extra 5-year warranty against parts and manufacturer defects, and we tend to stock a lot more of the Nivelco accessories. So this one here is for what you can see. It's got larger holes for allowing the medium to pass through and access the diaphragm. Also, Nivelco has heart programmable models. So you can actually program the depth up to half of the depth, especially on the NPK series, not the NCK. They have a larger range of quality accessories, extended warranty up to 5 years, and we are well stocked in New Zealand at our stores for common ranges. You typically 1 metre, 2 metre, 5 metre, 10 metre, 20 metre, and 50 metre depths. Next, we have our Intech brand, which is the INLLTC. Economical, well stocked in New Zealand, very good for water and diesel, and very thin, runny mediums. We stock that in the 1, 5, 10, 20, 50, and 100 metre depths, and it's our most cost-effective model. It's also available in a 0 to 5 volt output, and in the 10 metre range and above, they have a much smaller diameter, which is great for installation because it means it can go down a smaller pipe and make it easier for installs. The 1 and 5 metre depth models, they have a 26 millimetre diameter. We'll now go into the accessories that we have with Intech. You see a few images here. We've got the filters. We have a terminal box with our air filter and OVP, OVP being overvolt protection. We have the surge adapter, which goes with the Nivelco brand. We have the hanging clamps. We also have the heart modem for the Nivelco range, so you can reprogram the depth. We have also a different sort of hanging clamp here. I'll show a few of these as well. So this is the surge adapter for the Nivelco range. It's typically just a tube, but it allows the diaphragm to be even more recessed and protected from any thick mediums. Hanging clamps. You see here, this is the cable goes up here and loops here and back down, and the weight of the transducer on the end locks it in place so there's no strain on the wire, and all the weight is supported by this loop. With this model of hanging clamp, this is able to go into tanks. It has, I think it's about a 1.5 inch VSP thread, and that screws in. You can see here locking clamps for locking onto the cable, and also a watertight seal for the cable going down. Now also is the housings, the connection housings with the hydrostatic level sensors. This one here is the Jumo one, and when it's opened up, you can see the terminations. If you look carefully on the box, I don't know if you can see that very carefully. This is the breather filter, so it allows air to flow, but water not to get in. Obviously, watertight connections and an well IP rated box. We do have a Nivelco brand as well of that model. This is the NAA 102. You can see here. Now this one here, the filter is actually incorporated in the gland. So this allows the air to move, condensation to make it air to move so that condensation doesn't build up, and it does not allow water in. Now inside this one, we've got our built-in overvolt protection as well as our terminals. So this overvolt protection is available separately. We have those in stock. If for any reason you had lightning strike and it takes out the OVP, so they're available. Speaking of OVP, we also have our New Zealand made model, which is the LPN OVP. These are very economical, probably the cheapest model we have available, and typically this is installed at the top of the well, and if there's a lot of distance between the top of the well and your switchboard, then you'd probably have one at the other end at the switchboard end as well. That will divert any lightning strikes or overvolts away from the transducer to save the transducer and also to save any sensitive electronics at the end. We also have a number of displays available. In particular, when you want to see the level with a iron UP4 display made here in New Zealand and in stock, it can be scalable to whatever depth. So at the lowest level, it would come up with a 0. If you want 100%, it would say 100. If you had it programmed for, say, a 20,000 litre tank, you'd have 20,000. We also have the Shimmerton range of displays and controllers. Here we have the SRS13 controller, a lot thinner in depth. These are new and come with a lot more bells and whistles. And you can then, once again, at certain level points, switch relays and to indicate level points, high level, low level, and alarms and sirens and bells and whistles if you want to indicate to someone that it needs attention because it's not working, it's too low or too high. Also, we have the DIN rail mounted iron UP4 DIN. This is virtually the same as the panel mounted model with 2 relay outputs and a 4 to 20 milliamp retrans. So this would typically be installed at the well end or even on the switchboard, and can also retransmit the 4 to 20 milliamp analog signal almost to a PLC or some other device. We have our SR90 series displays, and you can see here is another Shimmerton model, and this one here is the SRS5. Similar to the SD16, we also have the SD24, and we have the SR1 and the SRS. So this is the SRS model. SD16 is the most common, and it's very similar to the UP4 range, but it has buttons on the front so you can alter the level and set points. The UP4 is programmed with software so that you can, so it's non-tamper. So if you don't want people to be playing with the settings, then you can do it from a laptop. Right, well that's pretty much everything, guys. Thanks for your time, everyone. I really appreciate you listening in today, and hopefully we'll see you at the next webinar, which I intend to talk about Shimmerton controllers. So stay tuned for in about a month's time, and I'll put that together. But thanks very much, everyone, and have a great day, and we'll see you next time. Cheers.